As scientific discoveries are made, the cosmos never cease to amaze us. If a few centuries ago we thought that Earth was the center of the universe, we now know that it is the third planet of the solar system, which contains 8 in total. This system is itself located in one of the arms of our galaxy, the Milky Way, which has about 230 billion stars. In front of these immeasurable proportions, we can only remain admiring the immensity of the universe. As for its observable part, it would contain 2,000 billion galaxies. It is then almost certain that systems compared to ours are distributed throughout the Milky Way, and even in the universe at large. The stars, these giant balls of glowing gas, are so bright that they're easy to spot, but as for the planets orbiting around them, the task is more complex. So complex that it was not until October 6, 1995 that astronomers confirmed the discovery of a planet outside our solar system. These distant cousins of our Earth are called exoplanets. Since then, thousands of them have been identified. If mankind is striving to unearth these new worlds, it is because they could teach us more about the formation of our own planet, about the origins of life, and even serve as a shelter for humanity in the more or less distant future. Exoplanets are almost invisible, and yet so numerous. They contain mysteries that intrigue the scientific community and fascinate astronomy enthusiasts. Dear traveler, good morning. Today we leave for a journey of several thousand light years to discover these other worlds. If not already done, we ask you to subscribe and like the video to support the channel. Thank you all, and happy viewing. The cosmos is full of space objects, such as sublime comets, luminous stars, destructive asteroids, or hungry black holes. Among this sidereal fauna are many beings that populate the galaxies without anyone really paying attention: exoplanets. This name designates all the planets that are not a part of our solar system, but that orbit around another star. They are also called extrasolar planets. These are part of their own planetary system, sometimes very different from ours. Generally, when an exoplanet is discovered around a nearby star, it is not uncommon to find one of its sisters hidden just behind it. In 2005, 10 years after the discovery of the first exoplanet, astronomers had already identified 155 of them. By July 1st, 2021, this number had grown to 4,777 in 3,534 different planetary systems. It is estimated that 5 to 20% of them are similar to Earth. As for the others, their forms are as diverse as varied. Some are true giants, even larger than Jupiter. Others are divided between a burnt part, constantly facing the star, and an icy part, always in the dark. The extrasolar planets can be telluric, like the Earth, and have an impenetrable atmosphere, like Venus. On the contrary, their atmosphere may have been swept away by a cataclysmic event, like on Mars. These outer worlds can also appear to us as gas giants. The surface temperature can be icy as well as hot, and rare elements such as diamond or gold can compose the majority of these unusual planets. However, those that interest scientists the most are exoplanets similar to ours. Unfortunately, there are many called and few chosen. But why are there so few planets that can potentially replace our world? For the simple reason that the appearance of life on Earth is almost a miracle. It was possible because a large number of elements were brought together to allow its development. If it is possible and even probable that life can take other forms, it is nevertheless true that only planets similar to Earth can accommodate the human species. Thus, researchers focus primarily on the discovery of planets similar to ours. To do this, they are interested in what is called the TSI for Earth Similarity Index. This index measures the resemblance of a celestial object with the Earth on a scale from 0 to 1. The closer the value is to 1, the more the body is similar to the Earth. To calculate it, scientists check 4 parameters that are the radius, the density, the temperature at the surface, and the speed of release. This last parameter corresponds to the minimum speed that an object must have to leave the attraction of a star, without taking into account the effect of its atmosphere. It is thus directly linked to the gravitational force of the considered star, and thus to its density. This index is a good indicator. However, it is far from being sufficient to determine whether or not an exoplanet is a good candidate to replace the Earth. Let's take, for example, Mars. The red planet seems today to be the most favorable for the development of life among all those which make up the solar system. Its similarity index with the Earth is 0.815. This is less than that of Venus, whose index is evaluated at 0.979. Yes, Venus is more similar to Earth than Mars, according to this tool. On the other hand, its thick atmosphere is very rich in greenhouse gases. Thus, the average surface temperature of the Shepherd star is 863.6 degrees Fahrenheit. In view of this data, our twin appears much more hostile. This is why researchers cannot rely solely on the TSI to select potentially habitable planets. They must also observe the distance of the planet from its star. Depending on its size and radiation, each star has its own habitable zone. The perimeter of this zone takes the shape of a ring, and each planet contained in this ring benefits from an ideal sunlight to allow the development of life similar to the one we know. Many other parameters must be carefully analyzed, such as the presence of an atmosphere. This one must be dense enough to protect the surface from solar winds. Its composition must not be too rich in greenhouse gases, nor so dense as to obscure the light. The presence of liquid water, the volcanic activity of the exoplanet, the presence of a moon, and so many other parameters are involved in the equation. If many exoplanets are discovered day after day, finding the one that can replace the Earth is far from being as simple as one might think. For scientists, it's like looking for a needle in a haystack. Of the billions of exoplanets scattered throughout the cosmos, the day will inevitably come when one almost identical to Earth will be discovered. In fact, despite the astronomical number of extrasolar planets, it was only in 1995 that the first was officially detected. But why did we have to wait so long before being able to observe these stars? The answer lies in their observation. In 1992, the Polish astronomer Alexander Wolfskan studied a very singular celestial body, the pulsar PSR 1257+12. A pulsar is a neutron star rotating on itself at an extremely high speed and producing periodic pulsations. However, the study of this pulsar led the astronomer to some very strange observations. In fact, the period of pulsation of the object was irregular. After having put forward various hypotheses, he concluded that the presence of 2 bodies, 4 times more massive than the Earth, was at the origin of this disturbance. It was the first indirect observation of a planetary system other than our own solar system. But the first direct observation of an exoplanet is attributed to the astronomers Michael Mayer and Didier Queloz in 1995. Located at about 50 light-years, the new planet they discovered was named 51 Pegasi b. Just like penicillin in its time, the discovery of this planet by the 2 men was the result of a happy accident. The 2 astronomers were looking for stars similar to our Sun. While orienting the huge telescope of the Observatoire des Hautes-Provinces, they discovered that the radial speed of the star was abnormal. After checking and rechecking, there was no longer any doubt. There was indeed an object orbiting around the star. In accordance with the nomenclature of extrasolar systems, this new planet was named 51 Pegasi, like the name of the star, and B in relation to its luminosity. The letter A is preserved for the brightest object of the system, that is, here, the star. 51 Pegasi b is a gaseous planet of large scale, comparable to Jupiter. However, it has the particularity of being extremely close to its star, at 4 million miles exactly. For comparison, Mercury is located at 32 million miles from the Sun. This was a surprise for astronomers, given that in our solar system, it is the telluric planets that are closest to the star. The period of revolution of this gas giant is only 4 days, and on its surface, there's a temperature of 2,000 degrees Fahrenheit. This unexpected discovery was, however, unlikely. It is for decades that man scans the sky, but most of the bright bodies that we see glittering at night are usually only stars. The others being the planets of our own solar system, such as Venus, the shepherd star. From Earth, exoplanets are very difficult to detect. But why? The reason is related to the atmosphere that protects and surrounds our planet, but also to the very nature of exoplanets. Unlike the stars around which they orbit, these distant planets do not emit very intense radiation. It is therefore not possible to detect them in this way, especially since the power of the radiation emitted by the star completely overshadows that of the planets. However, scientists continue to use the same method as that of Michael Mayer and Didier Queloz, namely to observe the variations of radial velocities of stars to detect planets outside our system. A significant variation of this parameter probably indicates that a massive body is in orbit around the star. However, to make such an observation, several conditions must be met. The planet must be close enough to the star for the gravitational force to be significant. Also, it must be massive enough, proportionally to the star, to have an impact on its radial velocity. This method limits the field of possibilities, and also requires very powerful telescopes. Astronomers have therefore turned to another method, the transit method. It consists in detecting a decrease in luminosity during the passage of a planet in front of its star. It is with this method that the most exoplanets were detected. The more the luminosity decreases at the passage of the planet, the more massive it is. Just like the measurement of the radial velocity, the transit method gives us indications on the size of the detected planet. But it goes beyond that by also giving us information on its atmospheric composition. When the rays of the star pass through the atmosphere of the planet, they are filtered. By comparing the raw rays and those that are filtered, scientists are able to establish the profile of the atmospheric composition. If it is made up of chemical elements such as methane, oxygen, carbon dioxide, or even water, this increases the chances that this planet could harbor life. Although this method is quite successful, it does have some drawbacks. For a planet to be detected, its orbital plane must be in line with ours. In addition, the transit method cannot be applied from the Earth's surface. The passage of a planet in front of its star causes a very small decrease in brightness. Because of the thick atmosphere that surrounds our planet, we're unable to say if the decrease in luminosity is in fact the result of a planet in orbit. The detection by transit method is therefore done with the help of satellites, specially designed to scan the cosmos in search of new worlds. The first of these was the Kepler satellite, sent by NASA in 2009. Its mission was simple: to identify as many exoplanets as possible in our Milky Way. To do this, the telescope was carefully equipped by the engineers of the American Space Agency. At the time of its launch, it had the largest mirror of all the telescopes in orbit around the Earth. Its equipment also included 42 CDD sensors for a total resolution of 96 megapixels. This is enough to cover about 25% of the sky surface. During its operation, the Kepler telescope discovered 2,662 new planets using the transit method. Unfortunately, the telescope's activity ceased in 2018 due to major malfunctions. However, the Kepler mission allowed us to highlight some characteristics of exoplanets. It seems that most of them have a size between that of our Earth and that of Neptune. This is called super-Earth. Kepler's observations also made it possible to affirm that most stars have at least one planet in orbit around them. The same year that Kepler was decommissioned, NASA launched a new spacecraft, also dedicated to the discovery of extrasolar planets. Its name? The TESS Space Telescope, the Transiting Exoplanet Survey Satellite. The research of the latter was essentially based on the discovery of planets with similarities to ours, namely telluric planets of small size located in the habitable zone of their star. As for the observed stars, TESS focused on those equivalent in size and brightness to our Sun, located as close as possible to us. The goal of the mission is above all to discover the potentially habitable worlds that are most easily accessible. Although at the moment, reaching these worlds seems utopian, it is not impossible that the discoveries of the telescope will lead to space exploration missions, or even colonization in the centuries to come. On March 23, 2021, NASA announced that the telescope had already discovered more than 2,200 exoplanets by scanning nearly 70% of the celestial sphere. Even more recently, the James Webb Space Telescope was put into orbit. Its launch took place on December 25, 2021. At present, it is the largest and most expensive of all the telescopes put into orbit. Unlike its predecessors, it is not only dedicated to the search for exoplanets, but aims to continue the work of the Hubble Space Telescope, that is to say, the observation of the universe in the broad sense. For NASA and the various space agencies around the world, these observation missions are crucial for the understanding of our universe. The telescopes in orbit, always more powerful, are not hindered by the thick atmosphere of our planet, and can therefore make increasingly fine observations. In its time, Hubble has notably made it possible to highlight the existence of supermassive black holes at the center of galaxies, but also the mysterious dark matter and dark energy. Perhaps the James Webb Telescope will be the first to provide proof that life has developed elsewhere than on our blue planet. For the moment, nothing allows us to validate this hypothesis, as fascinating as it is. On the other hand, the various observations of telescopes have brought to light very singular exoplanets, some of which are promising for the future of the human race. The one we will discover first is located in the Kepler 90 system. Located at a distance of more than 2,800 light-years is the extrasolar system Kepler 90. Recently, the latter has aroused the interest of astronomers because of the discovery of a new exoplanet, Kepler 90I. With this one, Kepler 90 is officially the first planetary system other than ours to have 8 planets orbiting a single star. The name of this system comes from the Kepler telescope that made the discovery. It was the 90th stellar object to be discovered during the mission. The 3 closest planets to the star, Kepler 90b, c, and I, are telluric planets, comparable in size to Earth. The next 3, Kepler 90d, e, and f, are gas planets slightly smaller than Neptune, and the last 2, Kepler 90g and h, are gas giants, similar in size to Jupiter and Saturn. This is a surprising feature because in our solar system, it is the larger gas planets that are closer to the star, which contrasts with the distribution observed in the Kepler 90 system. Also, the planets orbiting in this system are much closer to each other compared to those in our solar system. Kepler 90h, which is the most distant in the system, is about as far from its star as the Earth is from the Sun. This has sparked great interest in the scientific community, which still wonders how such a complex system can contain massive bodies at such a close distance and still be stable. If this extrasolar system is referred to as Kepler 90, it is also the name of the star at its center. Kepler 90 is a yellow dwarf, whose mass and radius are respectively 1.2 times those of the Sun. Its surface temperature is 10,472 degrees Fahrenheit, about 482 degrees Fahrenheit cooler than the surface temperature of our star. Although it is comparable to the Sun in size and temperature, the age of Kepler-90 is estimated at 2 billion years. It is therefore twice as young as our Sun. On a starry night, one might be tempted to observe this young star. Unfortunately, it is too dark to be seen with the naked eye from Earth. However, it is 1.7 times brighter than the Sun. This heat and radiation makes the stars Kepler-90b and c, those closest to the star, far too hot to be habitable. Their temperature is close to that of Mercury or Venus. Kepler-90i, the last planet discovered in the system, is the third in terms of distance from the star. This one was discovered like its sisters by the transit method. However, it gave a little more trouble to the analysts. A longer observation period and a data processing based on complex algorithms were necessary to detect it. Its existence was officially proven in 2017, making the Kepler-90 system the only planetary system with 8 planets outside our solar system. However, it is not impossible that other planets make up this system, and researchers are keeping a close eye on Kepler-90. Perhaps it has not yet revealed all its mysteries. If you're wondering what this planet might look like, imagine the surface of the Earth is nearly 932 degrees Fahrenheit, and you'll get a pretty accurate representation. In fact, this planet is similar to the Earth in terms of mass, diameter, and chemical composition. Only, its proximity to its star makes the development of any life impossible. In fact, none of the planets discovered in the Kepler-90 system at this time seem to be able to harbor life. But there is another system, just as interesting as Kepler-90, which seems more promising on this point. The latter, named TRAPPIST-1, would have at least 3 planets in orbit in the habitable zone of the star. On the cosmic scale, the TRAPPIST-1 planetary system is our neighbor. It is located at a distance of 39.5 light-years, or nearly 2 times 10 to the 14th miles. Even if at the moment this system seems unreachable, its orbit makes it slowly drift towards us. Who knows, maybe one day TRAPPIST-1 will be close enough to be explored by man. The star TRAPPIST-1 is what we call a red dwarf. These stars are the smallest and least bright stars in the cosmos. They shine at about 1% of the intensity of our Sun. They are therefore invisible to the naked eye from the Earth. On the other hand, they are the ones that populate the skies for the most part, and can burn for nearly 10 billion years. It is estimated that 80% of the stars in the universe are red dwarfs. For TRAPPIST-1, this status of dwarf star is not unfounded, since its size is similar to that of Jupiter. Although it is incomparably smaller than our Sun, TRAPPIST-1 is still its elder by about 3 billion years. To better understand the discovery of this system, we must go back some time, and more precisely to 2016. It is at this time that 3 exoplanets orbiting around TRAPPIST-1 were discovered through the transit method. This indirect observation is not the work of a space telescope, but of a terrestrial telescope, and more precisely, that of the ESO Observatory located in Chile. At an altitude of more than 2,600 meters, this observatory offers ideal conditions for space observation. Thus, the planets TRAPPIST-1b, TRAPPIST-1c, and TRAPPIST-1d were discovered, respectively. But by pushing the observations with the Spitzer telescope, scientists were also able to detect the presence of TRAPPIST-E, F, G, and H, for a total of 7 exoplanets. This is quite a large number, but it does not equal the Kepler-90 system. However, the planets of the TRAPPIST-1 system have a particularity that those of the Kepler-90 do not have. They are all identical to the Earth in terms of size. In fact, their radius varies between 0.7 and 1.13 times that of our planet. It is partly for this reason that TRAPPIST-1 is described as one of the most promising systems in the search for habitable worlds. After analyzing the density of these different planets, it appears that they must potentially contain significant amounts of water and other volatile elements. This is even more likely for the more distant planets, TRAPPIST-1 E, F, G, and H, which could be almost entirely covered with water. These planets would thus be comparable to a giant ocean, like the planet Miller presented in the film Interstellar by Christopher Nolan. If we look more closely at the planets of the TRAPPIST-1 system, we see that only 3 of them are located in the habitable zone of their star, respectively TRAPPIST-1 D, E, and F. TRAPPIST-1 B and C being too close to their star, their temperatures are too high to contain water in liquid form. As for planets G and H, they are simply too far away and do not receive enough sunlight to be habitable. Although some of these planets are promising in terms of their mass, composition, and surface temperature, their atmosphere must also be taken into account. TRAPPIST-1 being a red dwarf, it does not diffuse as much energy as our Sun. To benefit from the same conditions as our Earth, the planet must be closer. This proximity could make them uninhabitable. Stars sometimes have periods of high activity. If this happens, the solar winds and ultraviolet bombardment would be so intense that they could simply sweep away the atmosphere of potentially habitable planets. However, some research seems to show that planets G and H could have an atmosphere strong enough to withstand these periods of high activity. These hypotheses are still up for debate, and scientists are waiting to collect more data, especially with the help of the James Webb Telescope. But one thing is certain, they'll keep a close eye on this nearby system in our Milky Way. The search for Earth-like exoplanets sometimes runs into some problems. Although scientists have been able to identify more than 4,000 of them, many of these new worlds are not suitable for life. This is because all the factors previously listed, but also because of the detection methods. The transit method, although effective, allows essentially to detect massive bodies from super-Earths to hot Jupiters, because these stars cause a significant decrease in brightness when they pass in front of their star. Also, planets with a fast period of revolution are more easily detectable, because the number of passes in front of their star allows us to obtain a faster confirmation of their status. It is therefore the planets close to the bright star or those orbiting dwarf stars that are mostly detected, as for the TRAPPIST-1 system. However, among these many candidates that are automatically illuminated, one planet has caught the attention of scientists. In fact, it is one of the most likely worlds to harbor a form of life ever discovered at the present time. The name of this planet is Gliese 832c. It orbits the star of the same name, Gliese 832, which is located only 16 light-years from Earth and belongs to the constellation of the Crane. Unfortunately, this constellation does not contain many stars visible to the naked eye. If you look up in the sky, you will not be able to see Gliese 832, despite its relative proximity to the Earth. Again, this star falls into the category of red dwarfs, and its luminosity is just 7/1000ths of that of the Sun. However, the star is only twice as small in size. The habitable zone of the star is therefore very narrow. The planets orbiting Gliese 832 are subject to the gravitational force of the star, but also of their own rotation, and thus always present the same face. This is exactly the same phenomenon that occurs between the Moon and the Earth, or between Mercury and the Sun. There are 2 exoplanets in the system, Gliese 832c and Gliese 832b. For the search for potentially habitable worlds, Gliese 832c is the better of the 2 candidates. However, it is Gliese 832b which was discovered first, in 2008 to be exact. Because it is a planet in the category of superjupiters, its observation was easier than that of Gliese 832c. It was not until 2015 that the latter was discovered. The event was a general surprise, both for the press and for astronomers, since the analysis revealed a similarity index exceptionally close to that of the Earth, 0.81 to be more precise. In a movement for general enthusiasm, Gliese 832c began to be nicknamed the Second Earth. However, the planet presents notable differences with our world. The similarity index is calculated according to various parameters that take a more or less important weight in the equation. Thus, the study of Gliese 832c revealed that its mass was 5.5 times that of the Earth, and it takes the planet 35 days to make a complete revolution around its star. This short period of revolution is due to the fact that Gliese 832c is 6 times closer to the red dwarf than we are to the Sun. This also leads to a significant eccentricity. But what does this mean in practice? In astronomy, it is important to note that the orbits of planets are generally elliptical and not circular. This is due to many factors, such as the speed of rotation of the planet or cosmic shocks with asteroids that can disrupt its trajectory. The greater the eccentricity of a planet, the more pronounced the ellipse shape. This is the case for Gliese 832c. Because of this, it regularly leaves the habitable zone to return immediately. This must cause sudden rises and fall in surface temperature. Apart from that, the planet receives the sunshine from its star close to that being received by the Earth. The average surface temperature of Gliese 832c is estimated to be -4 degrees Fahrenheit, while that of the Earth's surface is more like 59 degrees Fahrenheit. The difference is noticeable, but not unfit for the development of life as we know it. But one parameter makes these statements uncertain. To its mother star, Gliese 832c could constantly expose the same face to it, and thus have a part always sunny and another much colder, always in the shade. This could cause major climatic disturbances on its surface, such as violent hurricanes, especially since its atmosphere is potentially very dense. Now, let's see what the surface of this planet could look like, assuming that it could harbor life. Knowing that its mass is potentially more than 5 times that of the Earth, its gravity would be drastically higher, but there's some uncertainty around this data. So it is impossible to know if the gravitational force on the surface of Gliese 832c would be too strong for us to bear. Scientists estimate that this force could well be 200 to 400% that of the Earth. Gliese 832c being a telluric planet, this implies that its reliefs would not be so important because of the crushing gravity. The crust of this planet would be relatively flat, with packed mountains and shallow oceans. Thus, this would favor the existence of liquid water areas, which is a crucial point for the development of life, at least as we know it. Given the rather low luminosity of its star, and especially its dense atmosphere, the sky on Gliese 832c must mainly have a twilight appearance. This one must be of a rather reddish tint, and the days rather dark. With its elongated orbit and its short period of revolution, the seasons on this planet must be quite marked, changing from week to week. Taking into account this frequent alternation between freezing temperatures and hot days, it is reasonable to say that if Gliese 832c harbors life, the species that inhabit this planet must have mechanisms of thermal regulation much more efficient than ours. We can also think that, depending on the period, these organisms are able to migrate rapidly to colder or warmer areas of the planet. Given the strong gravity on the surface of Gliese 832c, its potential inhabitants could well have a small and stocky silhouette, with a thick bone structure and a highly developed musculature. If they could migrate to our planet, these beings would then have the capacity to withstand much greater temperature variations. Without doubt, they would not need to consume as many resources to heat themselves as we do. Also, their strength would be prodigiously superior to ours, and they would be able to carry such heavy loads on their shoulders that they would be overwhelming for us. As for the plants, they would probably be quite dark, if not black, in order to attract as much light as possible, but also have deep and strong roots in order to resist the violent winds that rage on the surface. Of course, these are only assumptions based on the scientific data we have. These organisms could just as well be at the unicellular stage, or not be at all. Also, it is logical to think that if extraterrestrial beings do populate this planet, the most favorable zone for their development should be the junction between the lighted side and the dark side of the star. In this place, the temperature must be ideal enough to allow the development of organisms similar to those found on Earth. We can also think that the mountainous areas of the star can be used as protection and shelters against its tumultuous winds, which prevail at the level of this separation zone. Perhaps troglodyte beings inhabit the mountains of Gliese 832c, taking advantage of calm times to fish at the level of the oceans that cover the surface, as did our ancestors in ancient times. Because yes, if there is liquid water on Gliese 832c, it is probably located at the border between the exposed and hidden sides of the planet. The clouds that form in the hot zone are pushed by wind to the border, falling as precipitation, while the ice that covers the cold part of the planet gradually melts to feed the rivers. As for the very rapid changes of the seasons, this phenomenon could well produce the tidal effects caused by the moon on our planet. All this supports scientists' ideas that Gliese 832c can potentially harbor life. Unfortunately, at the present time, it is impossible to know. Realistically, this planet remains much less favorable than the Earth for the development of life forms. However, the discoveries made on our own planet prove that life is very adaptive, and above all, much more diverse than we can imagine. From bacteria insensitive to all kinds of radiation to creatures in the abyss, resistant to cold, phenomenal pressure, and the absence of light, we can only hope that our universe is as rich in diversity and that the Earth is not the only planet to have seen the birth of life. Our wonderful journey has taken us to the depths of the cosmos. For our next destination, we'll get closer to our solar system. In fact, we will observe the closest exoplanet to Earth ever discovered. In the southern hemisphere, to the left of the Southern Cross constellation and slightly below the famous Centaur constellation, lies the mysterious Proxima of the Centaur B. Its configuration is similar to that of Gliese 832c, which means that it orbits a red dwarf, Proxima Centauri, always presenting the same face. The interesting thing about Proxima Centauri b is that this planet was not discovered by the traditional transit method, but by the radial velocity analysis. By orbiting around its star, Proxima of Centaur b will cause a slight attraction of the latter, making it gradually approach or move away from our observation point. Through the use of Doppler effect, it is then possible to observe wavelength variations in the radiations emitted by Proxima of the Centaur. These variations were therefore indirect proof that a massive body must be orbiting the star. This body is none other than Proxima Centauri b, a star 1.27 times heavier than the Earth. Its period of revolution is only 11 days, but what is most surprising about this exoplanet is its proximity to our own. Proxima of the Centaur b is only 4.22 light-years away from us. In the search for potentially habitable new worlds, Proxima b is particularly interesting because it is located in the habitable zone of its star. From the analysis of its atmosphere, it appears that Proxima b could be a planet entirely covered with water, without even a continent to set foot on. This gives it a new common point with the exoplanets of the Gliese 832 system. But unlike Gliese 832c, the gravity on Proxima b would not be as significant. This means that the landforms on this planet would be more prominent, much like on Earth, with potentially 124-mile deep oceans. Just think, the Mariana Trench, which is the deepest of the oceanic trenches on our planet, is only 7 miles deep. So we know that Proxima b is in the habitable zone of its star, it is potentially covered with liquid water, and covered with an atmosphere. Also, due to its rotation, heat transfer could make the temperature viable on the entire surface of the planet, including its hidden face. Adding to this that its similarity index with the Earth is 0.87, the planet becomes one of the best candidates for the search of a new shelter for the human species. Unfortunately, there are some things that don't support this with such certainty. In 2017, astronomers observed a cataclysmic event that occurred near the planet. A gigantic solar flare was emitted from Proxima Centauri. This flare was 10 times brighter than the most powerful solar flare ever observed on our Sun. This gigantic explosion increased the brightness of Proxima Centauri by a factor of 1,000 in just 10 seconds. During this solar flare, Proxima b potentially received such a high dose of radiation that it could have wiped out any possible trace of life. Taking into account that other flares have already been observed on Proxima of the Centaur, Proxima b could well be a charred Earth without an atmosphere, a barren desert world like our twin, the Red Planet. Among the many worlds discovered by astronomers, some could indeed harbor life. This is the case of Gliese 832c, Proxima b, or TRAPPIST-1d. But during their research, scientists have also discovered planets and systems as strange as fascinating. The first one we will observe is located in the Gemini constellation. Within our solar system, only the Sun is enthroned and proudly radiates its light and heat. But in a multiple solar system, several stars share the spotlight. These systems are quite rare and consist of 2 or 3 stars trapped in each other under the effect of their gravity. But if you look at the Castor System, what you will discover is more than surprising. In this multiple system, each of the 3 central stars is in fact a binary star. This system therefore contains 6 stars. Compared to this, the planet Tatooine with 2 suns that the movie Star Wars presents to us has nothing extraordinary. Castor is the second brightest object in the Gemini constellation. Although the system is rather distant, since it is located at a distance of nearly 51 light-years, it is a newborn in the history of the universe. Its age is estimated at about 200 million years. In this particular system, the central star is none other than Castor AA. This star can easily be qualified as a giant, since it is twice as heavy, but also twice as big as our Sun. Although there are incredibly larger stars in our universe, such as Antares or Betelgeuse, we must keep in mind that 85% of the stars in the cosmos are smaller than our Sun. The 6 sister stars of the Beaver System orbit around the same center of gravity, called the barycenter. Together, they are 52.4 times brighter than the Sun. Even today, this system continues to intrigue scientists, as the number of stars it contains is very unusual. The origins of its formation are still debated. However, despite their numerous observations, they have not been able to highlight the presence of any planet orbiting within this strange multiple system. Discovered in 2016, Kelt 9b is simply the hottest exoplanet ever recorded. The planet is located towards the center of the Southern Cross constellation. Its reference star, Kelt 9, is located at the immeasurable distance of 620 light-years from Earth. This young star is currently twice as bright and twice as hot as the Sun. Even though the temperature of this star is 9,800 degrees Fahrenheit, the temperature of Kelt 9b is 7,772 degrees Fahrenheit. This is more than most known stars in our universe. On this planet, the laws of physics that we know are pushed to the extreme. Its spectral analysis has revealed the presence of iron and titanium in its atmosphere. In fact, the temperature on Kelt 9b is so high that even the metal evaporates and condenses into clouds on its underside. This means that it can literally rain metal. Faced with the bombardment of radiation that Kelt 9b receives, scientists expected to find a planet smaller than the Earth, progressively slimmed by the power of the blasts. However, their discovery was quite different, since Kelt 9b is in fact almost twice as big and 3 times as heavy as Jupiter. Under the effect of the radiation received by its star, the atmosphere of the planet has expanded to inflate like a balloon. It is also possible that the bombardment of ultraviolet rays that Kelt 9b undergoes causes a significant loss of material. Like comets, it would then leave behind a trail of glowing gas. Another remarkable fact about Kelt 9b is that it has a polar orbit and not an equatorial one, like most of the exoplanets we know. As for the star, its speed of rotation on itself is such that it comes to deform itself to take the shape of a rugby ball. This phenomenon is known as gravity darkening. As a result, the temperature at the equatorial region of the star is lower than at the poles. We're talking about a difference of 1,472 degrees Fahrenheit. Knowing that Kelt 9b orbits in only 36 hours, it is almost as if the planet changes season every 9 hours. At present, no one is able to explain why this exoplanet has such a particular orbit. While planets like ours are constantly bathed in the light of their star, others like Trace 2b are immersed in eternal night. Located at the astronomical distance of 750 light-years from Earth, this giant is 1.5 times heavier than Jupiter. It intrigued scientists at the time of its discovery because after being detected by the transit method, it suddenly disappeared from radar once it passed in front of its star. In reality, the planet had not disappeared, nor had it been occulted by something else. Nor was it the detection equipment used that was lacking. In fact, Trace 2b is one of the darkest planets ever discovered. It reflects only 1% of the light of its star. For comparison, even the darkest coal you can find reflects about 3% of the light that reaches it. As if this frightening darkness wasn't enough, research estimates the temperatures on its surface is 2,912 degrees Fahrenheit. From space, this planet is like an apocalyptic vision of what could have happened to Jupiter, the bright gas giant of our solar system. But for the moment, no statement can be made with certainty to explain the nature of this body. If Trace 2b is so dark, it is perhaps because its atmosphere is rich in strongly absorbing elements, like sodium, potassium, or titanium oxide gas. If you thought that Pluto, which is 4 billion miles away from the Sun, is very far away, you are not familiar with the planet HD 106906b. Its star, although a little hotter, is in every way similar to our Sun. One might think that if planets were to orbit around it, the more distant ones would have the place of Neptune. The more distant celestial bodies would not have enough gravitational attraction to form planets by accretion of matter or condensation of gas. This is why our solar system is bounded by a ring of asteroids called the Kuiper Belt. Neptune is located at a distance of 30 astronomical units from the Sun. For HD 106906b, this distance is 600 astronomical units. This represents 56 billion miles. These scales are so immense that it is impossible for the human mind to even conceive them. Scientists, dismayed by this discovery, cannot explain with certainty how a planet so far away could have formed. However, several hypotheses have been put forward. When a star is formed, it is rarely born alone. It is quite common that other nearby stars are born. This was also the case for our Sun. One of these stars, during its drift, could have taken with it the unfortunate planet HD, thus moving it away permanently from its mother star. However, the distances are so great that this hypothesis does not have consensus. Another theory is that a planet formed near the star and it was propelled out of its system, taking with it the now distant planet. But for this theory to be plausible, the ejected planet must have a substantially larger mass than HD 106906b. Unfortunately, this drifting planet has never been found. Although it is very far from its parent star, the planet described as a lone wolf is not dark. It is a giant, about 10 times larger than Jupiter. Because of this, the gases that compose it are so compressed that they become hot, even burning to be exact. The temperature at its surface is about 2700 degrees Fahrenheit, so it could be detected by infrared telescopes. In addition to its remoteness, scientists are not able to explain the strange orbit of this planet. Like Pluto, which does not orbit in the plane of the ecliptic, HD's orbit is very elongated and, above all, completely inclined. Maybe one day, research will be able to explain what gave such particular characteristics to this lonely planet. CoRoT is the name of a small satellite launched by a French team. When this satellite was put into orbit, scientists were rather doubtful about its usefulness. The object is the size of a drone and measures no more than 12 inches in diameter. But against all odds, the satellite detected in 2009 an exoplanet very similar to the Earth, and particularly close to its star. So close that it takes only 20 hours for this distant cousin to make a complete circle around its star. At the time of its discovery, it was the smallest exoplanet ever detected. It is also this proximity that made it possible to discover it by the transit method. Imagine, this planet is 23 times closer to its star than Mercury is to the Sun. Its distance from CoRoT 7 is only 1.3 million miles, or a little more than 6 times the distance from the Earth to the Moon. Although CoRoT 7b is close to its parent star, it is quite far from Earth, 520 light-years away to be precise. This planet falls into the category of super-Earth. Its mass is 8 times that of our own. As for its surface temperature, it reaches new heights. It is estimated at 4,532 degrees Fahrenheit. If it were possible to live on the surface of this planet, the Sun would appear 360 times larger than we see it now. Since CoRoT 7b always faces its star, there would be no sunrise or sunset. The day would be permanent, and we would be illuminated with an absolutely blinding light. CoRoT 7b is a telluric planet, which means that there is no heat conduction thanks to the gases present in the atmosphere. On this rocky planet, extremes of temperatures are present. On the illuminated side, the ground is a furnace crossed by flows of molten lava. On the other side, the dark part receives no light. The temperature is so cold that it approaches the absolute zero of the sidereal void. By analyzing the density of this planet, researchers have concluded that it is mainly composed of rock and iron. Remember, on Kelt 9b, the temperature was so high that the metal could evaporate and fall back as precipitation. Well, on CoRoT 7b, it rains rocks. Most of the iron on the planet is found at depth, covered by a rocky mantle. Under the effect of the extremely high temperature, the rocks of this mantle can evaporate and fall as solid rubble on the colder parts of the planet. For any life like the life we know on Earth, CoRoT 7b is a real hell. our journey took us to some of the most remarkable exoplanets in the cosmos. Fascinating because of their extreme conditions, or real puzzles for astronomers, they prove to us that space is full of mysteries that challenge the most imaginative among us. Speaking of mysteries, there are some of the 4,700 known exoplanets that push the limits of the strange even further. This is notably the case of WASP-12b, nicknamed the Egg Planet. The latter belongs to the category of hot Jupiters. It is so close to its star that this gas giant is being devoured little by little. Due to the colossal gravitational forces at work, WASP-12b is gradually having some of its material sucked up by the star, which has the effect of deforming it, giving it the peculiar shape of an egg. In a few thousand years, the planet will have been completely digested by its star. If WASP-12b will not resist the erosion of time, 55 Cancri e seems indestructible. At first sight, this telluric planet looks like ours, but by analyzing its chemical composition with more precision, researchers have made a surprising discovery. 55 Cancri e is covered with carbon. This one is in the state of graphite, but also, and especially, in the state of diamond. This precious composition can be explained by that of the mother star, which contains more carbon than oxygen, unlike our sun. If we lived on 55 Cancri e, a diamond would not be more valuable than a common flint. We could also imagine visiting other planets, like HD 209458b. On this one, wind power would be the preferred means to produce energy, as the winds are so powerful. On Earth, the strongest winds barely exceed 250 miles per hour. On Jupiter, its winds can reach 620 miles per hour or more. And on HD 209458b, the gusts of wind can get up to between 3,100 and 6,200 miles per hour. As if that wasn't enough, its surface temperature approaches 1,832 degrees Fahrenheit. Fortunately, there are other stars in the cosmos that make us dream more than have nightmares. This is the case of J1407b, an exoplanet located at 434 light-years from our Earth. If this one is nicknamed Super Saturn, it is simply because its ring system is 200 times more imposing. Another exceptional fact, the rings of the latter have a direction of rotation opposite to that of the planet. For scientists, this can only be the result of a natural disaster, whose origin will surely remain unknown. Yes, the universe is full of paradoxes, events which, at our scale, upset the laws of physics. On Gliese 436b, nicknamed Behemoth, the snow simply caught fire. As a result of this combustion, the planet releases an immense quantity of gas into the cosmos. This progressive evaporation leaves behind a magnificent cometary trail of 9 million miles. Our amazing sidereal journey has led us to the discovery of worlds, each more surprising than the last. Since the discovery of the first exoplanet a little more than 2 decades ago, thousands of planets have been discovered orbiting stars beyond our solar system. Many of these new planets are very different from those orbiting our sun, and even the architecture of exoplanetary systems bears little resemblance to our own. Over time, a surprising amount of detail has been determined for some of these distant worlds. What is even more remarkable is how quickly the field of exoplanetary research has developed in a relatively short period of time. Much of what we know about exoplanets, including extreme examples such as diamond planets and lava worlds, are still only tantalizing clues that require much more detailed and precise measurements before anything can be confirmed. New space telescopes have revolutionized the field of exoplanets, and we can look forward to exciting times with upcoming space missions. The existence of exoplanets is now established beyond doubt, and different detection techniques are probing space for a new range of planets. However, each method provides only part of the overall picture, and follow-up observations are almost always needed to confirm the nature of the planet. With the steady increase in the number and type of exoplanets, there's undoubtedly much to learn, and as we move from an era of exoplanet detection to an era of characterization, new areas of research may yet develop. For example, by analogy with our solar system, moons should exist around exoplanets, and these could provide potential habitats for life. The search for exolunes is underway, but none have been detected so far. Between super-Earths, potentially habitable planets, inhospitable worlds, and the strangest, some are even wandering without a sun, wandering at the bottom of the galaxy in permanent darkness. The cosmos has once again made us dream, thanks to its incredible diversity. More than the search for habitable worlds, the study of exoplanets is a major challenge to better understand our cosmos, the formation of planets, including that of our own Earth. This endless exploration could well teach us more about the appearance of life, and even lead us to discover new forms of life, which, like us, are only waiting for the first contact with external beings. Today, the missions continue, and more are to come. NASA has recently launched its new James Webb Telescope, and the launch of the Plato Observatory by the European Space Agency is planned for 2024. Every day, new planets are discovered, and each observation pushes the limits of our understanding of our universe a little further. It is perhaps only a matter of time before mankind will be able to penetrate the secrets of space. One thing is sure, these discoveries, as strange, frightening, or revolutionary as they may be, will continue to stir the imagination and hope of cosmic lovers.